Let's solve the step by step to express the given set in roster form. We're looking at the set of all integers where x squared is greater than 5 and x cubed is less than or equal to 36. Let's break this into two conditions and create a table to check different integer values. Our first condition is x squared greater than 5, and our second condition is x cubed less than or equal to 36. We'll create a table to evaluate these conditions for different integer values. Let's start checking values. 4x equals 0. 0 squared is 0, which is not greater than 5, and 0 cubed is 0, which is less than 36. Since both conditions aren't met, 0 is not in our set. 4x equals 1 and negative 1. 1 squared is 1, which is not greater than 5, and 1 cubed is 1, which is less than 36. Similarly for negative 1. Neither of these values are in our set. 4x equals 2 and negative 2. 2 squared is 4, which is not greater than 5, but 2 cubed is 8, which is less than 36. Neither of these values satisfy both conditions. Now for x equals 3 and negative 3. 3 squared is 9, which is greater than 5, and 3 cubed is 27, which is less than 36. Both conditions are met. These values will be in our set. 4x equals 4 and negative 4. 4 squared is 16, which is greater than 5, but 4 cubed is 64, which is greater than 36. Only one condition is met, so these values are not in our set. Looking at our pattern, we can see that for any integer with absolute value greater than 4, x squared will be greater than 5, satisfying our first condition. However, for positive integers greater than 3, x cubed will be greater than 36, failing our second condition. Therefore, our set in roster form includes negative infinity up to negative 4, negative 3, and positive 3. We can write this as the set containing dots negative 5, negative 4, negative 3, and 3. To verify our answer, we can check that all these values satisfy both conditions. Their squares are greater than 5, and their cubes are less than or equal to 36.